Okay, thank you all for attending our webinar this month. Today's topic will be our Modbus TCP data acquisition modules. We'll feature our ET7200 series in this broadcast, which has dual Ethernet ports. Here's our agenda for today. First, we'll go over Modbus communication in general. We'll discuss Modbus RTU and TCP and just do a quick synopsis of it. Next, we'll discuss our Modbus TCP data acquisition modules. We'll show a few typical configurations and show the cost benefit of our new ET7200, which allows daisy chaining of Ethernet communication. We'll go over our products, which are Modbus TCP. Then we'll go over some applications, and finally we'll answer some questions. ICP DAS was established in 1993. Our headquarters is in Hsinchu, Taiwan, and ICP DAS USA was launched in 2001 to support North and South American markets. ICP DAS is ISO 9001 certified. Our products are RoHS compliant, and we're a Windows embedded partner. Modbus RTU was developed by Modicon in 1979, now known as Schneider Electric. Modbus RTU is open source and royalty free, and because of this, it has become the most commonly used industrial protocol. It's a serial protocol based on RS-485 or serial wiring in general, with up to 255 devices that can be daisy chained along a single bus. Modbus RTU is a master-slave protocol which uses function codes to read and write data from slave devices. Modbus RTU only allows a single master device per bus. You can have multiple buses to expand networks, but I will go over some benefits of Modbus TCP in a few minutes. The master sends directed read-write requests to a specific slave device, and only the specific slave device will respond. Modbus RTU has several limitations. First, each slave must be daisy chained along an RS-485 or single COM port connection. Serial communication is very slow compared to Ethernet communication and many other industrial protocols out there. Networks must be planned due to distance and wiring limitations, because it's not very easy to, say, lay another RS-485 line or add anything to the bus. And it's great for small applications for up to 4,000 feet and up to 255 modules total, including the master. It can also be implemented over RS-232 as well, but for this discussion, we'll just assume everything's RS-485. Here's a typical application structure. You're allowed only one master. The master device can be a PC, a controller, a PLC, an embedded controller, or even a data logger, but you're only allowed one master device. And slave devices are daisy chained up to 4,000 feet along a single bus. You're not really allowed to do drops or branch off in different directions. We do have some solutions for that, but that's a separate discussion. Let's see, Modbus TCP was developed in 1999. The master-slave structure is similar to Modbus RTU, however, it is implemented over an Ethernet network. This allows for larger networks due to Ethernet communication being faster and more easily expandable. Devices traditionally have a unique IP address to differentiate slave devices and master devices. Modbus TCP has many benefits over Modbus RTU and just in general. First of all, Ethernet is everywhere. Modbus TCP is implemented over an Ethernet network. It's easily expandable and easily moved. Just simply plug into an existing Ethernet port, add an extra switch, connect to a device that's on the same network as the master or other Modbus devices. There's faster communication speeds because Ethernet communication is fast, and you can expand to additional devices through the internet as well. Modbus TCP allows you to have multiple master devices polling any of the slave devices on the network, unlike Modbus RTU. And it is very commonly used, so there's drivers for most software and hardware out there, like PLCs and controllers and data loggers. And hardware that's required for this is only an Ethernet port, which most computers, PLCs, and data loggers have built in. Let's see, with this picture, I wanted to show that a single master or multiple masters can pull data from the slave devices. So the master PC, PLC, or in this case touchscreen controller will place an inquiry or request for read-write data from the slave devices. The slave devices are differentiated by IP address, so only the slave device which is talked to should respond and reply with the corresponding answer to the inquiry from the master device. So if the master were polling the top device for the digital I/O status of the buttons and the light, what it would do is send out a request for the status of the lights, and the slave device would respond with the request. Then it will move on to the next device, poll its status for the digital I/O, and the slave module will respond, and so on and so forth. Modbus TCP is very easy as well. It's very easy to implement. You just simply use an Ethernet switch, or you can even plug a data acquisition module directly into an Ethernet port. The SCADA software or master controller must have a driver or built-in communication to allow for Modbus TCP communication as a master, and the slave devices have defined Modbus address tables based on the manufacturer and of the hardware, and the connection from the Modbus master defines the connection to the slave device by its IP address, usually port 502, and the Modbus address of that specific node. And then you reference the register or registers which you'd like to pull data, both read and write. And you can simply add additional slaves by getting a bigger switch or adding to another location which is on the same network as the master device. And this can be implemented by adding slave devices throughout the internet by networking through a router or through public IP addresses. Modbus TCP compatibility and Modbus RTU, because they're open source and royalty free, you're easily able to connect to third-party Modbus devices, and many of the most popular manufacturers already have communication capabilities to Modbus RTU and Modbus TCP networks. Modbus RTU does require a physical COM port connection, so you would need to have a COM port and a driver built into your hardware. Most automation hardware and software do offer some way to communicate to Modbus RTU and Modbus TCP devices, either through a driver, through OPC, using a gateway, or a communication port. Sometimes it requires additional hardware. Modbus in general is great for applications like PLC, where you need an extra couple of I/O, SCADA applications, data logging, and industrial automation applications. ICP DAS USA has several Modbus TCP data acquisition module series. This is the overview of most of the series. The TET are the tiny versions. The ET series is our middle series with single Ethernet ports. And the ET7200 is our new series, which we're highlighting in this webinar, which has dual Ethernet ports. I'll go over some of the benefits in a few slides, or the next few slides. The TET and ET series have dedicated Ethernet ports, or single Ethernet ports. Their I/O configurations are predefined, and there's specific models which we'll go over in a short bit. The number of I/O is smaller in the TET series because it only has 10 I/O pins. The ET series has 21, and the ET7200 has 22. Dimensionally, they're shown at the bottom with the T for tiny series being the smallest in footprint, and the ET7200 being slightly bigger than our ET7000 series. The P in the part number simply means that it has a POE feature, or power over Ethernet, which requires a special Ethernet switch which will supply power to unused Ethernet, or I'm sorry, unused pins in the Ethernet cable, as well as provide for data communication. Here's a side-by-side comparison of our ET7000 series with our ET7200. They both have terminal block connections, both top and bottom. Let's see, there's a run indicator and Ethernet indicator, but the main thing that I want to point out are there's a small reset button for the ET7200, as well as dual Ethernet ports. Traditionally, like I said earlier, it's easy to add a Modbus TCP data acquisition module to any network with an empty Ethernet port. By having two Ethernet ports, let's see, it allows the ability to daisy chain modules along Ethernet communication. Because of this, you only require one Ethernet port. This sometimes will help minimize the software or cabling required, because Ethernet requires, or can be, connect a module up to 100 meters away. If you laid a single device with a connection 100 meters, but you had 5 devices, you can this way, by daisy chaining, lay one 100-meter cable and then a few short runs to the accompanying modules right next to it. The ET7200 also has LAN bypass, which means that if the module is off or not communicating, communication will still go on to the next module. Compared to the standard Ethernet ET series and PET series at the top, which require one Ethernet port per module, so it may require additional switches or additional wiring to each slave device from the switch itself. The ET7200 series also has a few additional features. Communication security has ID, password, and IP. IP where it only allows communication from certain IP devices, so that for security purposes, if you want to prevent, I guess, outside people or other devices on the network from accessing the data, you could do that by programming the module. It has Modbus TCP and UDP, as well as CGI capability. The dual watchdog feature is built into both our ET and our ET7200 and ET7000 series. It's got power on and safe values like our other modules. This is for in case communication is lost. The module will go to a safe value, and the power on value is when the module is powered up, what status each output will be assigned or predefined. Let's see, the ET7200 digital modules also have LED indicators to show the status of each digital input or output. The reset button is only in the ET and PET 7200 series, and it's got a pair of power input pins as well, so you can have a redundant power source or redundant power sources. And notice again the dual Ethernet ports, which allow for the daisy chaining or ability to daisy chain. There are models of both the ET and PET, ET 7000 and ET 7200, which have power over Ethernet feature. One note, the PET 7200 modules have power over Ethernet, however, only the first module will be POE. Every additional module will require a separate power source, and power will not be passed through to subsequent modules. Here's a selection guide. Just shows part number selection. If the first block has a P, that just means it's a power over Ethernet version. The ET series is our Modbus TCP series. The 7 is in all the parts. The next digit corresponds with the number of Ethernet ports. A 0 refers to one Ethernet port, and a 2 in that placeholder will signify that it has dual Ethernet ports and therefore can be daisy chained. And the model numbers are consistent with our other series. We'll go over the selection table in the next slide. Okay, for analog input modules, we have these different variations. Starting with the ET 7005, that's our thermistor input module. We do not have a PET 7200 model for that yet. We may in the future, but these are our current selections. Note that for most modules we have an ET 7000 series. Not all of them have the PET version or the dual Ethernet port version. And our part numbers stay consistent, where a 17 refers to analog input module with those specific analog input types and a few digital output types. So the last two digits in the part number traditionally are the I/O configuration for our devices. For analog inputs, we also have thermocouple modules and RTD modules, which accept those types of inputs, as well as the traditional 4 to 20 milliamp and voltage inputs. We also have multifunction I/O. These are, again, just different I/O combinations. For instance, the ET7002 has 3 analog input channels, a few DI with counter ability, and a few DO. The 7204 series, there is no ET or PET series, but it's a new I/O configuration with an additional AI input or analog input. Because it has additional pins, it has the room to put in that additional channel. Let's see, note that the ET7016 and PET7016 will accept strain gauge input. Other than that, it's just additional modules with a different configuration. These show our digital I/O combinations. The DI modules can read the digital input status, and they have counters built in. So it's not only counters. And just has different numbers of digital inputs and digital outputs and a few different types. Note the 7053, where the 53 corresponds with dry contact, and the 7255 is also dry contact. Other than that, everything else requires pretty much a DC voltage for the input. This slide shows our relay output modules. So again, these have relays built in for the outputs, which are used for many applications. Note the maximum current limits for each of the relays and the quantity of, or number of channels. The 7261 has the most relay outputs per module. And finally, we have a few encoder modules which will accept quadrature and single direction pulses as well as bidirectional. Now a few application or just application pictures. This is the traditional application where you have a Modbus master on the left side. It's just polling and communicating to multiple slave devices throughout the network. This one, for some reason, says maximum 100 connections, but you could have way more than that. That's probably hardware-based. And you just configure your connection to each Modbus slave device and pull the data which you need in your program. Modbus and Modbus TCP are, easily the most popular protocols. Most SCADA software, including InduSoft, which we sell, has drivers built in and predefined for Modbus TCP and Modbus RTU communication, as well as most other industrial protocols. I/O pairing is an interesting feature which we have added to our Ethernet devices, which allows inputs on one module to directly trigger outputs on a second paired module. Therefore, you don't need a controller, you just need two modules and an Ethernet switch. Here's a nice application where it just shows essentially a doorbell, and when somebody presses the doorbell, it notifies by using an output that somebody is at the door. Then you can press a button and trigger the door to be open. So it's not automatic, but with the pairing feature, an input on one module could trigger an output on the other module and vice versa. And we also have modules which can do analog pairing as well, where an analog input value read in from an analog input can trigger a corresponding analog output value. This is great for some PLC communication and some applications where it's not possible to do communication other than Ethernet, and you want to say pass a 4 to 20 milliamp signal between devices which are separated by Ethernet. Here's some industries and applications where Modbus TCP is used in. Industrial automation, the most popular. SCADA applications. Solar power, wind power, manufacturing, conveyor. Data logging, which we have our Easy Data Logger software, which all of the modules which we discussed in this webinar are compatible with, and it's free to use for up to 64 tags. If you want to use it with more, there's an advanced version as well. Inspection systems, robotics, security, monitoring, vending machine applications. So for instance, if you had a vending machine at a certain site and you wanted to keep track of how many items are sold and when to refill, this would be a great application for that. Laboratories and automotive industry are great applications, as well as the solar and wind power. Okay, I'll open the mic, so if anyone has any questions, please feel free to ask, or you can also type it in the chat box. I believe our next webinar in January will be going over our power meter series. Let's see, so far I don't see any questions. If anyone has any questions, I guess click the button to raise your hand and I'll open the mic for you. Okay, if we have no questions, then I'll conclude or close this webinar. But please have a happy holidays, and we'll see you in January for our next webinar. Thank you for attending, and we'll see you next time.